Okay, class, I am really excited about today's lesson, and hopefully you're going to get excited as well. This is a great lesson today, and something that I'm looking forward to, but I must admit, most students do not. If you look, we are doing 7.6, solving motion problems using systems. What does that mean? All right, you don't need to write this, but you know what it means? We're going to do word problems. Man, aren't you excited? Aren't you excited? We're going to do word problems. And here's the thing. Look, I have to say this every year when we start word problems. Right away, a lot of you just went, oh, because you think that word problems are impossible. Now, I'll give you this. They can be tricky. But like anything, if you learn some tips and pointers, and if you can learn some structure, and that's what I'm going to teach you today, you can do word problems. You can do word problems. We're going to do problems like this. Two trains left New York. One traveling north at 87 miles per hour and the other traveling south at 113 miles an hour. In 7 hours, how far apart are the two trains? Something of that nature. And I know you think that that's basically an impossibility, but I'm here to tell you it is not impossible. Matter of fact, by the time we're done with this chapter, many of you are going to be able to solve a problem even more difficult than that one. So word problems. First off, it's your mindset. You have to believe you can solve them, and you can. Now, please pay attention to detail. Pay attention to detail. I've been teaching this for 30 years, 29 actually to be exact. And honestly, look, pay attention to detail. Over the years, I've tried to develop the details, a system that will help you to solve these. And you can do them. You can do them. So here we go. Are you ready? I'm excited. All right. Here we go. Number one. All right. With motion problems, and that's what we're talking about, right? Motion problems. It's going to start with a formula. And you guys know this formula already. I like to write it backwards, and I'll show you why in a minute. But rate times time equals distance. A lot of times they'll say distance equals rate times time, and that's true. Same thing, symmetric property, remember that. But we're going to use rate times time equals distance. All right, before we get going very far, let's make sure we understand what each of the variables stand for. R is the, and I hope you're thinking the rate, because I just said rate. What is rate commonly called? The speed, right? So we got the rate, which is the speed, T is the time, that's pretty easy, and D is the distance. Okay, so we have three parts. So underneath that formula, it says use the formula to form a chart. Use the formula to form a chart. All right, that's chart for you non-Jersey speaking individuals. And look, you form the chart by the formula. So look up above the chart. The R goes there. See my little raised dot there? The T goes there. And what does it equal? D. So I'll show you this when we get to an example down the road, how that formula will allow us then to form the chart. And so will other formulas allow us to form other charts when we're doing, for example, an interest problem. All right. So that's the beginning. We have a formula and we have a chart. Let's keep going. All right. What do you want to do next? You want to label the rows. So where does that take place? Out to the left of row 1. Again, this is a row, right? So that's row 1. This is row 2. And while I'm thinking about it, just so you understand terms, we have rows and columns. This is a column, right? It's the rate column, time column, distance column, right? Columns are vertical, just like columns on a house or building, and rows are horizontal. So the first thing you want to do once you get your chart set up is label your rows. Now, once we get to an actual word problem, I'll show you what I mean there, and that's not hard to do. So you label your rows. B. Now, this is a trick. Look, here's what we have to do. Look at the chart. There are 6 blocks to fill in. Don't write this in your chart. There are 6 spots we have to fill. And you got to figure out what goes in those 6 spots, and you want to get it correct. So we got 6 spots to fill in, and so we got to do what we can to make it as easy as possible on us, all right? So you got these 6 spots. So here's something that's going to help you. Fill in the variable. Fill in the variable column first. Now, how do you know which column is the variable column? Well, it's simple. It's what they're asking you for. Are they asking you to find out how fast? If they are, the variable column would be the rate column. And if that were the case, we would put in for the rate x and y. Again, don't put that in your notes, right? The variables would go in the variable column with the rate column, right? What if they asked you how long? That would be the time, and the variable column would be the time column, and you would put x and y in the time column. Okay, and if they asked you how far, that's a distance, and the variable column would be in the distance column, and you'd put x and y in for the distance in the distance column. Hey, that's easy. That's easy. But you know what? When you do it, that's going to take away 2 of the 6 boxes, and you only have 4 left. Hey, we can do this. You can do this. You really, 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 really can. C. C. Excuse me. Often the distance column, if you look to the example here to the bottom right, again, here is the distance column, right? So often the distance column comes from multiplying the rate times the time. Now, why in the world would you ever multiply the rate times the time? Look at the formula. Rate times time equals what? Distance. So it makes sense. So often, sorry about that, keyboard keep popping up. Often your distance comes from multiplying the rate times the time. So let's do row 1. The rate of row 1, 4, times the time of row 1 is x. I'm going to use my blue here, and I'm going to get 4x for the distance. Okay. I know you guys don't have purple. You can use red or whatever. In the second scenario, the rate, 7, times the time of y gives you a 7y. And we've completed our chart, and we're ready to continue on. All right, so doing word problems. What are you going to do first? You're going to write the formula. What's the formula going to allow you to do? It's going to allow you to make a chart. What are you going to do first with a chart? You're going to label the rows. What do you do next? Fill in the variable column. That'll leave you 4 boxes. Look back in the problem. It'll tell you a couple other things. In this case, we knew the rate. How would you get the distance? Rate times time is distance. Rate times time is distance. And you now have a completed chart. Okay? So again, pay attention to detail, and you'll be in good shape here if you'll pay attention to detail. All right, something just happened there. I have no idea what. Let's see if we can undo. Yeah, we cleared the whole page out. That would have been good. All right, so anyhow, let me go back in and fill this in. So we had 4x and we had 7y. All right. Wow. We are all different, aren't we? That's okay. We can leave it at that, and we'll work around it, and that'll be fine. All right. So again, often the distance comes from multiplying the rate times the time for that, and that should be row. For that row. Okay. All right. Let's continue on. If I can get past our... All right. Let me get my shade up. Sorry about that. Once I hit that back button, it deleted my page, and that then caused us to lose a little focus, but that's okay. We'll get there. Okay, trying to get lower here on the page. Electronic limitations, but that's okay. All right, look at D if you would, please. Sorry about that. All right, so now you have a completed chart. What comes next? Next, we have to write the equations. And this is a system, and a system contains two equations. So we have to write the two equations, okay? So we're going to write the two equations. So how do we know where to get our equations? How do we know where they come from? How to get them? How do we know what to do here? Well, like everything with a little bit of structure, we'll be in fine shape. So the equations will come from the columns that contain the variables. Okay, I can do that. Look at our example right here up above. Which columns contain the variables? Well, we have a time column in this example, so we would have a time equation because time column has the variables in it. And the variables are also in the distance column, so we would have a distance equation because distance has the variables within it. That's where we'll get our equations from, the columns that contain the variables. Okay? All right, let's keep rolling along. Now within that, there are two possible types of equations. Two possibilities here. What kind of an equation will the, for example, time equation be? What kind of an equation, for example, will a distance equation be? Well, there are two types of equations. The first type is a total equation. And a total equation has this template. The first plus the second will always equal total. Isn't that how you total things? Add up what you got. For totaling, we're going to add the first and the second. Okay, and I'll show you how to fill in the blanks there when we get to an actual problem, but that's the template. Anytime you have a total equation, that's your template. Every time. Every time you have a total equation, that's a template. And I'll show you how to figure that out when we get to a problem. What is the second kind of equation? You can have a total equation, or you can have comparison equations. You can have total equations or comparison equations. All right, a comparison are things that are compared. For example, I might be over 40 years older than you. That's a comparison. If I added my age and your age, we're probably going to be around 72. Oh, that sounds horrible. 71, maybe 70. That would be a total. If I said you're 7 years younger than me, that's a comparison. Right? If I said you're traveling 80 miles an hour faster than me, oh boy, I better not be going anywhere. That's a comparison. Um, if I said you traveled 5 miles farther than I did, that's a comparison. Okay? What is the template on comparison equations? It's always the first equals the second, but then you have to deal with the comparison. So what do you do after you make them equal? You have to add or subtract the comparison value from the correct side to make them equal. Some students can struggle with this a little bit, but again, I'm going to show you some common sense tips that will help you to add that amount or subtract that amount from the correct side. And it's not hard if you'll pay attention to detail. And I'll show you how to do that in just a moment. All right, so let me recap this section. The equations will come from the columns that contain the variables. So if you look back up here at this example again, we have two variable columns. We have a time column with the variables in it, and we have a distance column with the variables in it. So we're going to have a time equation and a distance equation. When you look at the original word problem, you would say, is the time a total or comparison? If it's a total, use this template. If it's a comparison, use this template. And you're going to do the same thing for the distance. Is it a total or comparison? And then use the template. Okay, after you do all of that, and I know that's a lot, now you still have to solve the system using substitution or elimination. See, we're still after the point of intersection, the x and y values that solve both equations. Okay? So that does make these long. So does that mean I'm going to give you 20 problems for homework tonight? No, I'm only going to give you 10. No, I'm just teasing. You're not getting that many either. Okay? So they are long. You got to pay attention to detail. There are many spots that you can make a mistake, but then again, they're also a great challenge and really a sense, you really feel like a sense of accomplishment when you're able to get one. So you can do this. Let's move on to an example. All right. Are you excited? Here we go. Real problem. All right. Take a look. I'm going to read it for you. At noon, a car leaves Chicago and travels toward New York. At 2 p.m., a car leaves New York and travels toward Chicago, going 5 miles per hour slower than the first car. If the distance from Chicago to New York is 803 miles and they meet at 7 p.m., how fast was each car traveling? All right, impossible, right? That's impossible. There's no way. We can't do that. There is no way. Well, we can. We can. So again, let's take a look at our structure. Do you remember how everything starts? It all starts with the formula. So off to the right here, give yourself some room. Rate times time equals distance. Spread them out because we need room for our chart. All right. So that's our formula, right? Okay. I know I need 2 rows for distance problems. And now I'm going to make a rate column, put a line right where the raised dot is, a time column, and here's something that's unique to my teaching. I include an equal. It's usually not that fat. It just turned out that way this time. But I do include a little equal column. You know what that little equal column causes you to do? It helps you to remember to come back and multiply the rate times the time to get the distance. That's what it does. Okay, we've got our chart. We're heading down the road. What's next? Label the rows. Okay, what do we have? What is the problem about? It's about a car leaving Chicago going to New York, and about a car leaving New York and going to Chicago. So there's a lot. You could call it car 1 and car 2. I like to be a little bit more descriptive to help keep track of stuff. So I'm going to put L for leaving and CH for Chicago, the car leaving Chicago. And I'm going to make the second one L and Y, New York, leaving New York. Okay. Now again, that you can really label any way you want, but I'm just telling you, you need to label in a way that you're clear which row is which. Okay? All right, we're labeled. What comes next? So flip back to the front there. What's the next thing you would do? All right, so we've just done this whole top part. We used the formula to form a chart. We got the chart all done. We labeled the rows. What's next? Fill in the variable column first. That's important. That's important. So we're going to look at our problem and we're going to figure out what do they want us to find. Now I helped us out on this first problem and I did it in red. How fast was each car traveling? All right, is how fast the rate? Is how fast the time? Or is how fast the distance? And everybody says it's a, and you should say rates. Awesome. Where do our variables go? In the rate column. There you go. Hey, we've only got 4 blanks left. What do you need to do? You need to look back at the problem and see if you can find another box. Now, if we were in class right now, I would say, all right, who can give me a box? And so you got 4 left, and somebody would say something like, well, the time is 87. And I would say something like this, okay, which time? the leaving Chicago time or the leaving New York time. They're different, and you need to be careful. So which time are you talking about? Okay, so let's look at the problem and see if we can figure something out. Now, nowhere does it say the car leaving Chicago traveled for 10 hours and the car leaving New York traveled for 3 hours. It doesn't say that. But it does tell us how to figure it out. So look at the problem. Right away, you get to at noon. That is a time. So at noon, a car leaves Chicago and travels toward New York. At 2 p.m., there's another time a car leaves New York and travels toward Chicago, but that's a different car. Let me stick with this Chicago to car, leaving Chicago. What else does it say about time? Keep reading. If the distance from Chicago to New York is 803 miles and they meet, if they meet at 7 p.m., that's when this first car, that's how long this car traveled, from noon to 7 p.m. And we all know that from noon to 7 p.m. is how many hours? 7 hours. So what's the time for the leaving Chicago? 7 hours. Hey, you can do that. You can do that. And sometimes it'll just tell you the car traveled 7 hours. In this case, you had to think of noon and 7 p.m. And we'll do the same thing with the car leaving New York. When did it start? At 2 p.m. When does it meet the other? At 7 p.m. How many hours is it from 2 p.m. to 7 p.m.? And I hope you say 5. Okay, we're rolling. We only have 2 boxes left. Do you remember how you get the distance? Well, remember, the rate times the time equals the distance, right? The rate times the time, so we're just going to multiply. X times 7 is 7x, and y times 5 is 5y. We have completed the chart. Awesome. We are rolling along. All right, what's next? We need our 2 equations. Our 2 equations will come from the columns that contain the variables. So look at your chart. Which columns have the variables? Well, I'm going to take my red here. We have a rate column with the variables. Go ahead and circle that in your notes. And circle that in red. I'm going to take my green. And we have a distance column with variables. I'm going to circle that in green. Okay. That's where our 2 equations are going to come from. All right, let's go orderly. Let's do the rate equation first. Now look, I label it rate equation. If you are wise, you will do this each time you do a word problem. Not only that, I'm going to put a parentheses. I'm going to say total or comparison. And if you're wise, you will say that every time. Now we have to figure out, are the rates in this problem given to us as a total or a comparison? Go back to the problem and read it again. At noon, a car leaves Chicago and travels towards New York. At 2 p.m., a car leaves New York and travels towards Chicago, going 5 miles per hour slower than the first car. Is 5 miles per hour slower a total or a comparison? And I hope you say a comparison. So we need now then to write the template for a comparison. So it's on the front of it's on your first page here. And it went like this. The first equals the second. Now, first what? Don't miss this. We're dealing with the rate right now, right? I know that because I labeled this. We're doing the rate equation right now. What is the rate of the first? Well, I'm going to help myself out. What is the first in this case? Leaving Chicago. What is the second in this case? Leaving New York. Okay, that helps me. What is the rate of the first? Go back to your chart. What's the rate for leaving Chicago? Rate for leaving Chicago is X. You see that? Look, I know where to go and where to look because I already said I'm doing the rate equation. So this is X. I go to my chart to figure out the rate of the car leaving New York, and it's Y. Now I've got to deal with one other thing. Let me go back here a minute. If you look on your bottom of your first page, add or subtract the comparison value from the correct side to make them equal. See, the template says set the two equal, but now you have to use the comparison to make them equal. The comparison to make them equal. Right? So here's what's going to help you to deal with this 5 miles an hour slower. We got to deal with this 5 miles an hour slower, and we got to figure out where to put the 5. Do you put it with X? Do you put it with Y? Do you add it? Do you subtract it? Okay, here's the way to do it. Here's the way to make it easy. It says at 2 p.m. a car leaves New York and travels to Chicago going 5 miles an hour slower. So what did it say? The car leaving New York is going slower. I'm going to come right here and I'm going to write slower. Slower. So if something's going slower, how do you get the slower side to equal the faster side? How do you get a slower side? You add the amount to it, right? You know, if the car leaving Chicago was going 80, the one leaving New York would be going 75. You got to add 5 to 75 to make it equal to 80. If the car leaving Chicago was going 65, then the car leaving New York would be going 65 miles an hour slower. You got to add 5 to make them equal. This label right here of slower, sometimes you'll say faster, sometimes you'll say less, sometimes you'll say more, will help you to know what to do with the comparison amounts. Okay, we got our first equation. I know you're saying, wow, there's a lot to this. Yeah, I know. But you can do it. It just takes some structure. Okay, now we need our second equation. Look at the problem. Our second equation is going to be a distance equation. And again, if you're a Y student, you're going to write distance equation. And if you're a Y student, you're going to write parentheses total or comparison. And then you're going to look back at the problem and you're going to look for something that talks about distance. All right, second line all the way to the right, if the distance from Chicago to New York is 803 miles. Now, is that a total or comparison? Is it telling you that one car traveled 803 miles less or more than the other? No, that would be a comparison. It's a total. From Chicago to New York is a total. And really, here's what's happening. You know, we'll make this Chicago. You need to write this. And if this were New York, one is traveling this way and the other is traveling that way. And this distance here is a total, right? That's what's going on. Okay, so let's do a template for our total. Our total template is always the first plus the second equals the total. Again, first plus the second equals the total. That's your template every time for a total equation, every time. Again, what is our first? Leave Chicago. What is our second? Leave New York. Now, remember, and you got to keep track, we're dealing with distance. What is the distance of the car leaving Chicago? Look at your chart. It's 7x. That's the distance. What is the distance of the car leaving New York? Look at your chart. It's the 5y. What is that total? Look back at the word problem. It said 803 miles. Shoo. All right. We've got that done, and we're ready to roll. Now I have to decide, how am I going to solve this thing? Am I going to solve, I'm going to do it over here to the right, solve by substitution or elimination? Look at your two equations and think about the two methods. So you can pause the tape right now if you want and think about it, or I'm just going to tell you, look at this top equation. It's already solved for x. I'm going to circle it because that's what we do once we solve one equation for one variable. Therefore, this is best done by substitution. So let's go through and solve this thing, all right? And I got to speed up a little bit here. I know our time has been going. All right, we're going to do substitution. Let's take our second equation, 7, and where the x is, we're going to put a parentheses, plus 5y equals 803. Let's sub in our value. So what is x? Look in the blue circle part. X is y plus 5. Okay, let's go ahead and I'm going to continue on in black here. Distribute. 7 times y, 7y, 7 times 5, 35, plus 5y equals 803. Let's move the 35. So what do we get? 12y, should be back in black here. 12y equals, what is this? 768. 768. Things multiplied times the variable, you move by multiplying both sides by the reciprocal, or do our shortcut. We'll divide both sides by 12. Let me grab my calculator here. And that's what you would do, right? So 768 divided by 12 equals, nice round number. Makes me happy, 64. Now, in any word problem, you have to figure out what your 64 is. Not a problem. We have a chart, and our chart helps keep everything straight. Look at your chart and figure out what y is. What is y? The rate leaving New York. And the rate in this problem is in what? Miles per hour. So y is 64 miles per hour. Now, how do you get the other one? Remember, substitution. Go back to your circled equation. And x will equal y plus 5. Put the 64 in for y. And x is 69 miles per hour. And the last thing you want to do is you want to be descriptive. So remember, x is the car leaving Chicago. So 69 miles per hour leaving Chicago, and 64 miles an hour leaving New York. Hey, we did it. We solved the problem. It's amazing. It's remarkable. All right, we're going to set up the second one and not finish it off until you begin to see that it's the same thing. All right, I'm going to go a lot quicker here. You can pause the video at any time you want to do things on your own. First thing, formula. Rate times time equals distance. We know we have 2 rows. Need a rate column, need a time column, need a little equal column, need a distance column. What's next? Label the rows. Sandy leaves Charlotte traveling at 60 miles an hour. Sandy, I'll do SAN. Pastor Souza leaves HCS 1 hour later, traveling at 68 miles an hour. Okay, all right, Pastor Souza. And I've labeled my rows. All right, what's next? Fill in what first? The variable column. So you got to look at the problem and figure out what it's asking you for. You read the problem. At what time do they pass? See that last line? At what time do they pass? Okay, time is time. Where do the variables go? In the time column. Awesome. Only 4 blocks left. Can you find another block from the word problem? Again, pause the video if you want to do it yourself. Sandy leaves Chicago going 60 miles an hour. What's Sandy's rate? 60 miles an hour. Pastor Souza is traveling at what? 68 miles an hour. That's his rate. Okay. How do you get the distance? Remember, rate times time equals distance. 60x, 68y. There we go. What do you got to do now? 2 equations. Where do I get my equations from? The columns with the variables. I'll have a time equation. Let me grab my green. And I'll have a distance equation. All right, let me do my time equation first. Again, if you're a wise student, you'll label time equation. You do parentheses, total or comparison. And we got to figure out, Is the time compared or totaled? Pastor Souza leaves 1 hour later. Is later a total or later a comparison? Comparison. What's our comparison template? First equals second. And again, I'm going to label. This is Sandy. This is Pastor Souza. Okay. All right. Now remember, we got to go back to the problem and figure out what's going on. So it says Pastor Souza leaves 1 hour later. He left later. So I'm going to put left later. Now to me that says less. I hope that'll say less to you. Because remember, with any comparison, we have to add the comparison. And so we have to do this 1. Oh, didn't do my variables yet, did I? I'm sorry. Let's fill in our blanks here. What's the time of Sandy? Look at your chart. Time of Sandy is X. What's the time of Pastor Souza? Look at your chart. Y. Now let's do that 1. Do we add 1 to Sandy? Do we add 1 to Pastor Souza? Do we take away 1 from Sandy or take away 1 from Pastor Souza? Actually, you can do it 2 different ways. If Pastor Souza left 1 hour later, he traveled 1 hour less. So let's add the 1 hour to him so they'll be equal. There you go. All right. Let's get then to our distance equation. Again, if you're smart, you'll write distance equation. You'll do parentheses, total or comparison. You'll look at the problem. If it's 388 miles, see that second line? If it's 388 miles from HCS to Charlotte, is that a comparison or a total? That's a total. Template, first plus the second equals the total. Who's the first? Sandy. Who's the second? Pastor Souza. Total. Look at your chart. What's the distance for Sandy? Look at your chart. 60x. What's the distance for Pastor Souza? Look at your chart. 68y. What is the total? Look up at the problem. 388 miles. There you go. 2 equations. How are you going to solve? You're going to use substitution or elimination. Now here's usually the way it goes. If one of them is a comparison and the other is a total, you almost always use substitution because look at the comparison equation. It's already solved for one of the variables. That makes substitution the best method. When both are total equations, and we'll do some of those problems, then usually you'll use elimination. Okay? I don't have time to finish, but when you go to solve this, be careful. When you solve, if you get X, what would X be? Look at your chart. What would X represent? Go to your chart. Your chart tells you everything. X is the time for Sandy. So you got to be careful. It says at what time do they pass? So you'll find out the total time Sandy was traveling. All right? And then that allow you to get the time of day. And then if you solve for Y, you'll find out the total time Pastor Souza was traveling. So if Pastor Souza, let's say he was traveling for 6 hours. Start at 10 and go 6, 11, 12, 1, 2, 3, 4, 4 p.m. Again, I don't know if that's the answer, but that's what you would do to solve it. All right, I know that's a lot. It's a big topic. I know this video is a little bit longer than normal, but look, it's here now for you. You can come back and look at it again. I'm telling you, you do the exact same stuff over and over again. You can do this. You really can. You can do it. Come on in class tomorrow, and I'll help you through it. All right. Have a great night.